Hello everyone, welcome to today's session. In this session, we are going to continue that the basic terms as well as the basic concepts in the solid mechanics. First parameter is called first terminology. Here we are going to look on is stress. First of all, what is stress? It is a familiar word to all, but we are going to look on only materials here. So what is the stress in materials? It is nothing but the resistance offered by the body to meet with the load is called stress. How much force is acting on the material and how it responds for the area contacted, that is called stress. The unit of stress is Newton per meter square. So based on the mathematical empirical relation, force divided by unit cross-sectional area. So here cross-sectional area is the important thing. We are not going to focus on surface area. Here force per cross-sectional area is called stress. Then the unit of stress is Newton per meter square. We can have different types of stress. One is tensile stress, another one is compressive stress, and one more thing is called shear stress. Generally, the force per unit area, if the force is axial force, then the stress may be tensile stress or compressive stress. Tensile means the force is pulling on. You are going to stretch, so it will expand. The length will be stretched. That is called tensile. So that kind of force is applied. The stress created or induced is called tensile stress. Then compressive force, if it is acted upon on a material, the unit cross-sectional area, the stress induced is called as compressive stress. Compressive stress, that means we are going to compress it. So the length on the particular material or the force is acted upon, the length will be reduced. So that kind of stress produced on that material is called compressive stress. Finally, shearing stress. So it is a sliding force. So due to the sliding force, the stress is produced. It's called as shearing stress. That is called shear stress. Shearing load per unit area is called the shear stress. Then the next thing is called strain. Is a basic terminology. If the material is loaded, then it is stressed as well as it is also strained. So what is strain? Strain is nothing but it can be defined as the change in dimension to the original dimension. How much dimension? That means if you are taking length, so how much length is increased or decreased for the original dimension is called strain. Actually, we are having two types of strain. One is linear strain, another one is called lateral strain. Linear strain, actually it is represented by the letter called small e. Linear strain. Linear means it is representing the terminology called length. Okay. So the terminology, the dimension we are going to take in linear strain is length. So change in dimension by original dimension. Here we are going to take the length. So change in length by original length we have to focus on. As well as another strain is called lateral strain. So we are going to focus the lateral dimension. Lateral means it is the perpendicular dimension to the linear dimension along the length. Here we are going to have another dimension perpendicular that is 90 degree. Okay, so horizontally it is linear, so lateral, that perpendicular direction is called the lateral direction. In that other than the length, if you are taking a cubical one, you are having a length and width thickness. So neglecting the length, you can consider thickness point of view or breadth point of view. Okay, That kind of strain is called as the lateral strain. This means a change in width to the original width or change in thickness to the original thickness. If you are taking a cylinder, we are taking the cylinder. So we are having length as well as the cross section is here circle. So we have a diameter. So change in length by to the original length in the cylinder can take a linear strain. If change in diameter to the original diameter, that kind of strain is called the lateral strain here. Next is called another basic concept. One law is there, that is the Hooke's law in strength of materials, that is mechanics of solids here. Hooke's law, generally it is defined as or states that the stress is directly proportional to the strain within the elastic limit. That is very important terminology or a statement called within the elastic limit. Beyond the elastic limit, the Hooke's law will not be valid. So we should state that, sorry, already it is stated that the Hooke's law is nothing but the stress is directly proportional to the strain. The stress may be tensile or compressive. Generally, it is called axial stress. So stress by strain is equal to Young's modulus. From that, we can have another parameter. We can have that Young's modulus. That means stress by strain equal to Young's modulus here. That is, stress is directly proportional to strain. So directly proportional symbol can be eliminated by adding on a constant here. The constant is material constant. So Young's modulus is a material constant. So what is the significance of Young's modulus? That is another question. So Young's modulus determines how much strength it has for bending. Higher the Young's modulus value, higher the resistance for bending of the material. As well, if the Young's modulus is lesser, then bending will be maximum. That means it easily tends to bend. For taking the material for aluminium, the Young's modulus is 70 gigapascal. But for steel, it is 3 times the value. That is 3 into 70 gigapascal, so around 210 gigapascal. So we know that aluminum can easily bend. When compared to the aluminum, the steel cannot be able to bend as easily. Okay, that is the significance of Young's modulus value. The next one is three elastic constants we are having. One is Young's modulus, what we have discussed so far. Another one is called shear modulus, that is the modulus of rigidity. Then another one is called bulk modulus. The modulus of rigidity, it is represented by the letter capital G. So shear strength to the Young's modulus is nothing but stress by strain. Accordingly, here shear modulus equal to shear stress by shear strain. As well as bulk modulus, generally it is related to the volumetric strain. That means change in pressure to the volumetric strain. That is called bulk modulus. Actually, whenever the modulus the terminology comes, the unit is also Newton per meter square, because it's a modulus. The Young's modulus we have, so stress by strain. Stress has unit of Newton per meter square, but strain, since it is a change in dimensions to the original dimension, so unit is nil. There is no unit at all. As well as for shear strain, sorry, shear modulus, bulk modulus, everything is stress by strain only. So there is no unit for strain, but the modulus has the unit of stress only, that is Newton per meter square. Then we can have another parameter called Poisson ratio. Poisson ratio, generally it can be represented by the letter mu, or generally it is 1 by m. M doesn't have any terminology. For a notation, it is being given as m, or it is generally 1 by m is equal to mu. So how can we define it? It is nothing but the lateral strain to the linear strain or longitudinal strain when the material is stretched. So a lateral strain by linear strain generally is given as negative value, negative signature symbol. Why it is a negative symbol? Okay, let's have our material. We just have a stitch that is tensile. You can pull it off. What can in the mutual direction, that is perpendicular to the direction, it is called a lateral direction. So one is increasing, at the same time the opposite, that is the mutual lateral dimension will get reduced. If it is compressed, this will elongated. So one side is increased, other side is decreased, vice versa. So Poisson ratio is equal to minus lateral strain to the longitudinal strain it is being given. The typical value of the Poisson ratio ranging from between for most of the material 0.3 to 0.5. But for cork, it is 0. So there is no change in the lateral to the linear. For rubber, approximately it is 0.5. Exactly the value is 0.4999. So these are the typical values. For steel, it is 0.3. So these are the Poisson ratio values should be taken care of. We should keep in mind everything. Okay. As well as a shear modulus, bulk modulus, we can have it already. Other is called a factor of safety. Factor of safety, it is used in the design purpose. Let's have on chair. Okay. Let's have on chair. One chair is used for sitting for a one man. But while designing, they are making a factor safety as instead of one, they can have, put it into three. So for one person, the maximum weight is equal to consider 80 kilogram. So if they are taking factor of safety is 3, that means 3 times the value of the weight of one person. That is 3 into 80, 240 kilogram is the maximum weight. That is ultimate weight. Ultimate weight. Here this can make it converted into stress also. Okay. So generally, factor of safety is equal to ultimate stress to the working stress. So even it is designed for one man, we are having factor of safety as a design factor in order to avoid the fracture. So factor of safety is maximum more than 1 or 2, 3, and based on the applications we are fixing here. And what are the different types of loads in the beams? Generally, we are having it is static load, dynamic load, impact load, thermal load, point load, distributed load. But in beams, we are using generally it is a point load as well as the distributed load. In distributed, we are having uniform distributed, and other is uniform varying load also. Then what are the different types of supports and reactions? So we are having fixed support, pinned support, roller support. These are the supports and reactions. Whenever the support is there, perpendicularly the reactions will be there. We will have how many reactions for each and every support. We will deal with in the next chapter in beam. What are the different types of beam? Generally, it is a simply supported beam, cantilever beam, overhanging beam, fixed beam, continuous beam. These kind of types of beams are there. And bending moment, shear force are the very important terminology we are going to use in the beams also. Moment of inertia we have already studied in the engineering mechanics. It quantifies the beam's resistance to bending. Generally, it is I is equal to integration of y squared dA. For rectangle, it is BD by 12. For circle, it is pi d power 4 by 64. We already studied here. And torsion in circular shafts also. So it is in the unit 4 we are having. Generally, we are having the theory of simple torsion. That equation is very important. T by J is equal to tau by R, which is equal to G theta by L, where T is the maximum torque, J is the polar moment of inertia, T is tau by R, tau is the shear stress, R is the radius of the shaft, G theta by L, where G is the shear modulus, theta is the angle of rotation, that is angle of deformation in radian per length of the shaft. As well as in bending also we are having theory of simple bending, theory of simple torsion. M by I equal to sigma by Y equal to E by R, where M is the maximum bending moment and I is the moment of inertia, sigma is the bending stress, Y is the maximum distance from the neutral axis, E by R, where E is the Young's modulus, R is the radius of curvature. And we are having columns and buckling. What is the eyeless buckling load and the stress strain curve? So these are all the important things we will discuss in the next class. Thank you all. Thank you for watching my videos. Thank you, and all. We will